Okay, good afternoon everyone, and welcome to our activity for this afternoon. A debate with the topic, resolve that synthetic function is the best method to use in solving or finding the remainder of a polynomial function. In the proposition stand, we have Rowena, Jerry J, Nilmalin, Ivy Joy, Dimple, and Kimberly. And for the opposition group, we have Jefferson, Johnny, Jose, Sheila, Harrison, and Laika. So let us now start. Or by the way, we have also our judges for this afternoon. We have Mr. Alberto A. Angelia, a math teacher, and we also have Mrs. Concepcion R. Hindayan, a Rintalikunan teacher, and of course, our secondary school principal, Engineer Jose Rami T. Pacibor Sr. So let us now start with our opening statement from the proposition stand.
Okay, good afternoon everyone. We are here to defend our side on how to find a remainder of a polynomial by using synthetic division. Synthetic division is a shorthand or shortcut method of dividing a linear factor. This method of getting the remainder of a polynomial is generally used not only for dividing out factors, but also finding the zeros or roots of polynomials. In addition to that, synthetic division is very useful for students who suffer difficulties in finding the quotient of a polynomial in using long method. Since synthetic division is a shortcut, we can easily get the remainder and the quotient of a polynomial. The process of synthetic division are the following. If you are given p of x equals 2x cubed minus 8x squared plus 19x minus 12 divided by x minus 3. First, write the coefficients only inside and upside down division symbol. Make sure that the coefficients are arranged depending on the power of their exponents. Equate the zero. Thus, we have x minus 3 equals 0. By using the addition property of equality, we get x equals 3. Put the value of x, which is 3, to the left side of the division symbol. Put down the first coefficient and multiply it to the divisor. Their product will be placed below the next coefficient. Step 2. Repeat the steps until you're in the last coefficient. Okay? For example, p of x equals 2x cubed minus 8x squared plus 19x minus 12 divided by x minus 3. So in synthetic division, 3 is separated by a division symbol. So we have 2, negative 8, 19, and negative 12. Then bring down the first coefficient, which is 2. Then 2 times 3 equals 6. And add it on the second coefficient, which is negative 8. Negative 8 plus 6 equals negative 2. Then multiply to the divisor 3. Negative 2 times 3 equals 6. Negative 6. Then add it on the third coefficient, which is 19. 19 plus negative 6 equals 13. Then multiply to the divisor 3. 13 times 3 equals 39. Then add it again on the last coefficient, which is negative 12. Negative 12 plus 39 equals 27. The number will stand as the remainder of the polynomial. So 27 is the remainder.
Okay. Thank you very much for your good points, proposition group. Now let's have the opening statement of the opposition group.
Good afternoon, everyone. Our group opposes that synthetic division is the most convenient way in finding the remainder when a polynomial is divided by another, because for us, the most convenient way or method in finding the remainder is the remainder theorem.
The remainder theorem states that if a polynomial
polynomial p of x is divided by x minus c, where c is a real number, then the remainder is p of c. The remainder theorem is a useful mathematical theorem that can be used to factorize polynomials of any degree in a neat and fast manner.
The remainder theorem also states that when you divide a polynomial p of x by any factor, for example, quantity x minus a, which is not necessarily a factor of the polynomial, you'll obtain a new smaller polynomial and a remainder, and this remainder is the value of the polynomial of p of x at x plus a.
Remainder theorem operates on the fact that a polynomial is completely ones by its factor to obtain a smaller number, or a polynomial to a remainder of 0. This provides an easy way to test whether a value a is the root of the polynomial p of x.
For example, given polynomial p of x and also given that is a root of polynomial, then when p of x is divided by the factor a, quantity x minus a, the result should be a smaller polynomial p of x and a remainder 0.
The remainder theorem starts with an unnamed polynomial p of x, where p of x just means some polynomial p whose variable is x. Then the theorem talks about dividing that polynomial by some linear factor, x minus a, where a is just some number. Then, as a result of the long polynomial division, you end up with some polynomial answer, q of x, where q is standing for the quotient polynomial and some polynomial remainder r of x.
Let us have, for example, the equation p of x equals 2x cubed minus 8x squared plus 19x minus 12 divided by x minus 3. So by remainder theorem, the divisor must be equated to 0, making it x minus 3 equals 0. Then, to obtain the value of x by addition property of equality, x equals 3. So p of x equals 2x cubed minus 8x squared plus 19x minus 12. Substitute all the x's by 3. So p of 3 equals 2 times 3 cubed minus 8 times 3 squared plus 19 times 3 minus 12. Then perform the operations. It becomes p of 3 equals 54 minus 72 plus 57 minus 12. The answer is p of 3 equals 27. And that is the remainder. That is how easy to apply the remainder theorem in finding the remainder.
Okay, thank you very much, opposition group. Now, we will get ready for our rebuttal. Let's have first from the proposition stand.
We have already said a while ago that the remainder theorem is easier than synthetic division. If we will use the remainder theorem in getting a remainder of a polynomial, we are going to substitute the value of x in all the coefficients having the variable x. The question is, what if the degree of the polynomial is in a bigger number?
Okay, if the degree of the polynomial is in the bigger number, since we already know how to multiply, right? All we have to do is to multiply the base to its exponent and add patience. That's it. Okay, what's the point?
So what if the given equation is not arranged from highest to lowest degree, or some terms are missing? There is a great tendency that you will skip or miss writing down the numerical coefficients.
I know that we have enough knowledge with this topic, which is the synthetic division. If there's a missing term, then put 0 to replace it. Then, proceed with the process of getting the remainder using the synthetic division. There's nothing complicated with that.
Also your point.
In addition of that, you cannot say that only the remainder theorem have a bracket of bigger exponent, because also the synthetic, because if you have example an exponent of 20, then you add 1. So we have 21 constant terms to be multiplied and add. So how can you explain that?
It is more complicated to use the synthetic division since there are steps, difficult steps, or there is a complexity of steps since you are going to arrange and not to forget to place 0 to the missing term. Whereas if you use the remainder theorem, all we need to do is just to substitute the x. So it is better to solve in a longer time to obtain the remainder safely than to use a complex method having the big probability to miss some terms.
It is better to use synthetic division in finding the remainder of a polynomial because synthetic division provides not only the remainder but also the quotient of the given polynomial.
The topic here is not finding the quotient, but finding the remainder.
Even though you cannot obtain the quotient, you can get the remainder easily. Remainder theorem is the specialized way of finding the specific remainder.
Yes. Okay, thank you so much for that wonderful debata. So let's now have the final statement from the proposition group.
Our group choose the method called synthetic division in finding the remainder of the polynomial because this method of dividing out factors provides not only the remainder but also the quotient of the polynomial.
Yes, thank you. What about the proposition group?
Well, for us, it's up to us to choose either of the two methods we will use. But on the general, we prefer to use the remainder theorem. But anyway, in some cases, we are also using the synthetic division.
Okay, thank you so much. So after hearing all your points of view from the proposition and from the opposition group, let us now ask from our audience of what is also their sides about the topic that is being shared to us. So from the audience, may I ask, what is also your side? Are you on the side of the synthetic division or for the remainder theorem, and why? Yes, Presley?
Both of the things are very informative because they give their brilliant ideas to defend their sides and to share with us the type that synthetic division. But unfortunately, I need to choose one that is very clear and realistic. So, I'm in favor in synthetic division. It's because, as what I have observed, compared to remainder theorem, it gives a total package of quotient and remainder, wherein in remainder theorem, it shows only the remainder as a result. While in synthetic division, not only the remainder, but also the quotient that we need to know. That would be all.
Okay, very well said. Thank you so much. Another one from the audience. What about at this side? Yes, Marlo.
In this debate, I favor the synthetic division because synthetic division is complete answers that the remainder theorem. It's hard but complete answers with remainder and quotient.
Okay, thank you so much, Marlo. Now let us hear from the remainder theorem side. Yes? You can see.
In this debate, I favor with this group the remainder theorem is good because it is so easy and reliable to get the remainder. We'll just substitute the value of x and that's it. We'll get the remainder.
Okay, so you feel it is easier to use. Okay, another one from this side. Ruel.
On my side, I'm favor to remainder theorem because in remainder theorem, you will easily substitute the value of x to get the remainder. Whereas in scientific theorem, there is a possible that you will confuse to arrange the missing term or you will mistake to identify the remainder.
So you do the same with the remainder theorem. You feel comfortable and easier to use. Okay? Another one. Yes, September.
Based on my observation in this debate or in these two groups, I am in favor in that group which is the synthetic division. Because synthetic division has a shortcut method and it is very easy to solve. Because because you will just simply multiply and add the given number and the answer will give the quotient and the remainder. While the remainder theorem also it is very easy to get the remainder, but for me there is a little bit confused, so that I choose the synthetic division. That's all.
Okay, thank you so much, Ms. September. Now, after hearing the points of the objects, let us now ask some feedback from our judges. So, yes, we will have our very own principal, Mr. Ramiti Pakibor.
After hearing your excellent arguments, rebuttal, self-expression of your opinion, I have been able to make my decision. First of all, I would like to thank and congratulate our teacher, Mrs. Lisa Aristones, for holding this debate successfully. You've got a job very well done. For the pros and cons team, you're able to discuss and explain your side clearly. Based on my evaluation and simple judgment, you've got an equal weight and arguments of reason. Pros, you have a very good reasons to argue. Cons, you have also an excellent point of rebuttal. Therefore, it is a question of choice and mastery. What matters is what you have mastered. However, with the use of our modern technology, like the different gadgets that we have, calculators, computers, iPad, and whatever gadgets that we have, it makes mathematics problem easy to solve. Thus, either you are using synthetic or remainder theorem, it doesn't matter. So congratulations to all for a job well done. Continue to be a very good debater. And you will bring also the glory of our institution if ever you will come to debate with other schools. I am hoping for that you will maintain your good, excellent talent for being a good debater, and I am hoping that you will be successful in the future. So, mabuhay tayong lahat.
Thank you very much, sir, for such wonderful feedback. So before we will end up in this activity, I would like to give you an assignment, which is you are going to write a reflection of what you have learned with this lesson. Write in at least 100